Yes, we can start, yeah? Good. Well, thanks very much for kind of coming in this morning. I'm Gojko, and I want to talk about our journey last year moving from Heroku to AWS Lambda. We've moved a collaboration platform kind of pretty much completely into Lambda now, and it's been a really interesting journey. There's a couple of things that we've kind of done horribly wrong that hopefully I can prevent you from doing if you decide to do something similar to that. And generally, I think the whole serverless platform, although it's kind of buzzword filled and there's a ton of confusion what actually it is and what it isn't, is one of the most revolutionary things that happened in IT architecture over the last 10 years. It's probably the biggest shift in what we can do as developers since 2007, when Amazon enabled people to spin up a virtual machine in a few minutes. And I was kind of looking at this with some colleagues a few months ago, where we just kind of joked how much the spin-up time is reduced over the last 10, 15 years. About 10 years ago, when Amazon was kind of releasing their first version of the cloud, I worked as a consultant for a big telecoms company on implementing some kind of software for them, and we were a third party. We delivered our crap, and they were supposed to kind of just spin it up, and it took them 9 months through their internal bureaucracy to get a virtual machine allocated. At this point, it's pretty much easy to now think about Amazon giving people the ability to spin up something in about 5 minutes at that same time, and seeing how that was obviously going to win. With AWS Lambda, the spin-up time for a new container now, if you're running Node.js, is less than 1 second. Which is completely crazy, because it starts changing constraints that we were working under. Simon Wardley, who used to run Canonical and then started writing some really, really smart books on where IT is going, has this theory that a huge amount of what we call best practices today in software architecture and design are still influenced by the average time to recovery that was a major constraint 20 years ago. Because if your machine died 20 years ago, you'd have to buy a new machine, you'd have to get people to come into the data center, install it. The average time to recover is a few weeks. And that's how we developed all these good practices like blue-green deployments, failover servers, multiplicated deployments, load balancing, and a ton of other things that we now take for granted. Now, with the average time to recover of less than 1 second, the big question is which of these best practices are no longer relevant or important? Which of these things are just shackles that we're running with because we are used to develop applications like that, we're used to deploy applications like that, and that's why I think the whole kind of serverless Lambda thing is revolutionary. Pretty much all the cloud vendors have jumped on the bandwagon. I think Microsoft is doing Azure Cloud Functions now. Google is Azure Functions. Google is doing Google Cloud Functions. IBM has this thing called OpenWhisk. There's a bunch of other people kind of running services like this. So I think we're in very, very early stages of what this is actually going to open up, because it truly changes the constraints under which we're developing systems. Now, I'm just going to throw some numbers at you that I discovered on the internet 5 minutes ago. And, like anything discovered on the internet, it might be completely irrelevant or a lie. But kind of Gartner estimates that in 2019, 75% of corporate IT spending is going to be on third-party platform services. So that's opening up a massive, massive opportunity for software companies to offer some, services in the cloud and grab some market there. And for me, at least, the whole serverless thing, if you take away the buzzwords, is what platform as a service was originally supposed to be before it was completely hijacked by the marketers. Because it actually allows us to use platforms as a service, and it allows us to offer something as a kind of as a service to other people. Amazon, a couple of days ago, enabled people to sell access to their APIs. So you can build an API, you can launch it on Amazon, you can use Amazon billing to basically provide people your service. And it runs on the whole kind of serverless infrastructure there, which means that if you can find a good business model where kind of the cost of the service is less than what you charge, that's basically it. You make money, and you don't have to worry about managing servers, security, installing, operating, and a ton of other things. It just takes a lot of kind of that headache away. The other thing that I found as a statistic on the internet 5 minutes ago is that IDC estimates that in 2020, 67% of the software is going to be running on the public cloud, because nothing else is going to make sense economically. And I think the whole pricing of Lambda as an offering is pretty much more revolutionary than the technology. The kind of technology behind serverless is not really particularly new. It's been around for at least 5 years. What's really revolutionary about the whole thing is that Amazon is now at such a kind of high utilization point that they can bet that it's better for you to pay for what you actually use than to pay for reserved capacity. Lambda is charged per 100 milliseconds in the processor, which means that if I have 1 million users now, this very moment, I will pay for kind of all that usage. And if they all go away in 1 hour, I don't have to pay for anything. And that means I no longer have to think about reserving capacity. I no longer have to think about provisioning machines. I no longer have to think about a ton of other things, because the economic cost of that is gone. A huge amount of how software architecture is kind of built and how we design, and my brain is still hardwired to think about reserved capacity. We design our applications to kind of think about, well, we're going to have 50,000 users next month, then we're going to have 100,000. Then now we need to kind of failover machines. We need to do distribution. We need to do this. We need to do that. Where one of the kind of most important things about this whole new platform offering is taking that thinking away and the platform being responsible for stuff like that. Where I'll give you an example why I think that's important. About 7 years ago, I worked with a gambling company where we had lots of different payment providers. And the way we'd kind of structure this thing is we do all those nice design practices, solid isolation, loose coupling, everything, TDD, brilliant stuff. And we'd create these nicely isolated modules that in theory do not influence each other. And then, because it was so difficult to secure and provision machines, we'd put 30 of them on the same machine. And we had a bug in one stupid payment provider that basically caused it never to release resources. And over time, kind of it took all the ports on the machine. It kind of, then the machine started freezing up. Then the failover machine started freezing up. And then we lost all the payment providers for a couple of hours until people figured out what's going on. Because we took all these kind of small isolated modules and we bundled it into an application, because kind of reserving capacity for the application was important. We had one machine. And then kind of we kind of pretty much ruined it for us, because when it was all bundled, it was difficult to monitor. It's very, very difficult to know that, oh, this particular module is kind of causing problems when it's all running in the same application server. And things like that were kind of forcing us not to benefit from small isolated modules during deployment. When we started deploying MindMap to Heroku, something very, very similar happened. We have, I don't know, 20, 30 exporters for different formats. Some of them are used quite often. Some of them are used very, very rarely. I think I'm the only person that's using the Markdown exporter. I built it for myself. I use it once a month, and that's pretty much it. The PDF one is being used several times a second. The SVG is being used, I don't know, once every minute or so. And because we were paying Heroku per virtual machine, it made absolutely no sense to provision a separate virtual machine and a failover virtual machine for each of these. Because the whole capacity of 30 exporters we can do with 3 virtual machines. Why on earth would I pay 10 times more? And this got us to bundle all the exporters into the same application, then deploy it somewhere where we can secure, scale, deploy it easily. And then we had a bug in the SVG exporter that again kind of caused resources to go out and caused the temp space to fill up, and then all the other exporters kind of started breaking because Linux doesn't work that well when you fill up the temp space. And then the failover exporters broke, and then everything kind of went south. And again, it's this thing where, because we had to think about reserving capacity and kind of bundling things together, we ruined it for ourselves, where with serverless platforms and technologies, you're effectively paying for usage. So there's zero benefit putting the SVG and the PDF exporter together. They cost absolutely the same if they're separate or together. And even worse, because it's memory times CPU. If one of them, like the PDF, is a memory hog, and another one, like SVG, is not really using any memory, it actually costs more to bundle them together. So I think this is the first time, at least in my programming career, that a deployment architecture is providing financial benefits for good design. Where if you do it badly, you pay more. And it's very, very clear that you pay more because you're paying for reserved capacity for a memory you're not using. And if you separate it out into small isolated modules that kind of can work independently, then you pay less. So that's kind of a really interesting thing. So the third number I stole from the internet is Gartner's estimate that in 2016, the value of the cloud market was $32 billion, which makes software the second most profitable cloud on earth. The most profitable cloud is, of course, marijuana, which is at 40 billion. And that means that in 2017, software is going to be bigger than drugs. Think about it from that perspective. And the estimate for the next 10 years is that the value is going to grow to about $208 billion for kind of cloud offerings and the cloud market. And that's kind of completely insane. IDC estimates that cloud migrations are growing at double the speed of virtualization, how virtualization was growing 10 years ago. And that means if you're not already in the cloud, you're pretty much going to be in the cloud in the next couple of years. And if you are 20% in the cloud, you're going to be 70% in the cloud in a couple of years. And this is where I think that the whole offering of all these different serverless services, however idiotic that sounds, is going to be absolutely amazing. And I have kind of two small children, and I've learned there's kind of three types of toys when you kind of think about it from that perspective. So the first type of toys is Lego. The whole purpose of Lego is the joy of assembling. That's kind of, you spend the time assembling the whole thing, and after you've done it, it goes on a shelf somewhere, and that's pretty much it. The kids do not play with the assembled Lego toys. The second group of toys, that's kind of probably 90% of the toys, are those stupid toys where you buy them in a box, and then it takes half an hour to assemble until the children can play. And that's a mess, especially if you forget to buy batteries and you're taking it as a present, because then they can't play, and it's all a mess. And I think that's where most of kind of how we deploy software is now. And the 10% of the toys that I think children find really, really enjoyable to play with are the toys that come with batteries included. And the big thing about serverless for me is kind of serverless is actually code with batteries included. Because what they've done is they've taken away almost everything that's not your business code. All of that is provided by the platform. And that's one of the most amazing lessons for us as we were moving things from Heroku to Lambda is how much code we've deleted. I think we've dropped about 1/3 of our code, which means that we have 1/3 of code less to maintain. We have, we're paying 1/3 less for development, for testing, for maintenance, and everything else. And we're benefiting from these services that were built for Amazon scale or Microsoft scale. And if you think about it from this perspective, there's probably very, very few companies that can do infrastructure as well as Amazon or Microsoft or Google. And from a kind of running a business perspective, it's much, much better to actually kind of use their infrastructure for that than use yours. And the lovely thing about Lambda is you actually get all those things for free. It's kind of included in the price of what's on offer. So I'll do something that nobody's supposed to do and try and do a live code deployment now, just to show you what the batteries included mean. So, okay. So I'm going to cheat a bit and I'm going to use a deployment tool because it would take too long to just configure everything through the website, and I hate websites. So what we're going to do, we're going to create a web API. I'm going to just initialize a new NPM project and NPM install a utility library to configure APIs. And I'm going to install a cloud deployment tool. And that's pretty much going to be the slowest part of the process. So now I can create something called API.js. And let's do it this way. So it's easier to see. So I'll say this is kind of the configuration helper. I'm going to create a new API. And I'm going to export it. And then I do get/hello. And we're going to say, hi there. That should pretty much be it. Let's see if I've kind of made a stupid mistake. So I can now say, we're going to deploy it to US East 1. And we are going to tell it your API module is API. Hopefully that's it. Now, if I've not made a stupid mistake typing this, this should kind of go live in a couple of moments. So it's now deploying this whole thing to AWS Lambda. And we are going to create a web API that is not really active yet. It's deployed, it's created there in their registry. And I have a URL now that I can go to and spin up a new container. So I've called this thing /hello. So if I do curl this thing /hello, we should get hi there. So kind of, now, as I said, what I like about this is kind of it's code with batteries included, because although this is very, very simplistic, with this thing, I get automatic scaling when more people come in. So if 1 million people start hitting this thing now, that's not a problem at all. If nobody hits it, that's fine. It's kind of not really working with anything. I get automatic monitoring. I get automatic statistics. I get automatic crash reporting. I get automatic security, because I can secure this in kind of lots of different ways that Amazon is offering, using API keys, using usernames and passwords, using IAM roles, using federated logins, using a ton of other things that you generally need when you're kind of building an application, but it's not your business code. It's a bunch of infrastructure. So if we go to now, I will kind of try and spin up just to show you this stuff now. So if I sign into my AWS console and go and, come on. So I have a new Lambda function called NDC London. I have kind of monitoring set up on invocations and stuff like that. So I need to select the latest things. So I get, there was one invocation, there was the duration, number of errors, throttles, and a ton of other things that generally people need when they're building applications. I have completely centralized logging that is telling me what got executed, when it got executed, how long it lasted. I have log collection through all these services. So if I have 1 million people hitting this thing now and 1 million containers spin up, I already have centralized logging. That's kind of, you know, the first month of building up a stupid application. And that's what I meant when I said code with batteries included. Kind of the whole infrastructure thing is just there magically at Amazon scale or at Microsoft scale. And I think this is a fantastic opportunity for people to kind of build up new services. Because really, most of it is just kind of, most of the headache that is potentially interesting if you like building Lego bricks is, you know, is gone, unfortunately. But if you're really trying to run a business, to spin up a business with software, most of the infrastructure headache's been taken away. And that's kind of the serverless part of serverless. So in terms of kind of batteries being included, the stuff that we've not really had to worry about since moving to Lambda is scaling. This does require a bit of a rethink how the application is structured. But once you do it right, the platform takes away the role of deciding how many containers to run, how many containers to shut down, when to do it, when not to do it. And again, you're not really paying for containers even if they're sitting there and not doing anything. You're only paying for the container when it's actually doing something for you. So the whole worry about, well, you know, do we need 5, 10, 15, how do we scale it up, at what point do we scale it up is gone. The big problem with kind of automatic scaling and things like that is, of course, kind of the whole monitoring thing. And at least Amazon has fantastic monitoring capabilities there, partially because they need to be able to charge us the right amount of money. And that kind of opens up some really, really interesting possibilities, because with such a low-level breakdown of billing, this is the first time, at least I've been able to say, well, this module of code is costing me this amount of money to run. Is the SVG exporter profitable? Is my login function costing me too much? Do I need to use a different database? Do I need to do? And a lot of these kind of enterprise architecture decisions that are based on gut feel that, so, you know, it's too much operational cost, or we need to descale this, or we need to scale this up. You get like an X-ray monitoring into how much things actually cost and how much run on a very, very miniature scale. So it's an incredible, it's an insane amount of visibility kind of that it comes for free with this. The next thing that we've never really had to worry about with Lambda for kind of a year running in there is recovery. And that's, again, going back to what Wadley was talking about. Mean time to recovery is really relevant now, because the containers spin up and die on their own. We've kind of engineered the app not to count on any container surviving. So mean time to recovery is irrelevant. I count on every request being executed on a potentially new container. And this, you know, that enables us to open up some really, really interesting things around, well, you know, how do we cache things? Do we cache? Do we not cache? How do we kind of load balance stuff, or do we care about load balancing or failover at all, and things like that? And in most of those cases, kind of it's just gone. The next really amazing thing that I think is one of the biggest advantages of the platform like this is proper support for versioning. I don't know how many times I worked with people that start doing feature flags and then shoot themselves in the foot, and the code becomes a horrible mess of spaghetti and nobody can maintain it anymore. Where with Lambda, I don't know about the other serverless platforms, but with Lambda at least, you get for free the way Amazon is doing multi-versioning for their code. Every single deployment gets a numerical index, and you can invoke any single version of your function that you've deployed ever. I can deploy a new version of my API, it gets a new numerical index, and I can call both. And the beauty of the whole thing is, because I'm just paying for usage, it costs me absolutely the same amount of money to have 20 versions deployed and to have a single version deployed. If you think about the whole kind of lean analytics space and lean startup and everybody talking about how you need measurements and testing and things like that, most of the stuff that people talk about in that space is front end. because front end is the easiest thing to A/B test, and the front end is something that kind of people can actually measure easily. But to properly A/B test stuff, you probably need two completely separate deployments. Now, that costs an insane amount of money for most people because it costs twice as much than to run your stuff. If you want to run 20 experiments, you need 20 separate deployments. And then, because it costs 20 times as much, what people do is they will kind of deploy everything on a single platform, and then you have experiments kind of messing each other up and polluting the data and things like that, because it just costs too much to operate 20 different copies of a system. With Lambda, it costs exactly the same amount of money to operate 20 versions, 500 versions, or one version, because you're paying for usage. If you have 5% of your users using this and 95% of your users that, same as you send 100% to each of those versions. So that opens up some really, really interesting possibilities, and I think experimenting on code like that, and generally kind of versioning code like that, up until a couple of years ago, was only possible if you're Facebook. I spoke to some guys in Australia a few months ago, and they were completely pissed off because Facebook is apparently constantly broken in Australia. Australia is a big enough market so they can run statistically valid experiments there. Everybody's speaking English, so they don't have to translate the software. So kind of experimental versions of Facebook features get released there and then measured, and then, they piss people off there. Once it starts making money, they deploy it to US and Europe and things like that. And this was only possible if you're running at Facebook scale. Now, Lambda gives you something like that for free. All the versions of your functions, you can kind of load the A/B test, you can ABC test, you can kind of balance. The infrastructure is provided there, and that's absolutely amazing. And this also allows us to kind of slice development completely differently. What we started doing a lot with MyMap is we develop a feature so we know it's going to be slow. And we actually release it to 10% of the users. And we can do pretty kind of well targeting, and we can say, oh, we've developed this so only people with about 100 nodes can actually use it. And then we can direct people who have a map of 100 nodes to that new version of the function. We can send people with kind of the larger maps to the older version of the function that's still stable and experiment on this. And I think this opens up some amazing opportunities for people that would just cost a stupid amount of money 5 years ago, and that you now get for free. And I mentioned the last thing that kind of Lambda pretty much provides for free is this kind of whole centralized logging. It doesn't matter how many versions you have, how many different kind of deployments, how many containers, the logs go into the same place, which makes it very, very easy to kind of figure out what's going on. And they're still improving this. I think they released last month a new product for tracing inside the code and things like that. That's also working at this level. And these are typically things that building up even on kind of second generation cloud, it's Heroku or Google App Engine, it's very, very difficult to figure out what different parts of the software are doing because it's all bundled together. And now we get this kind of amazing visibility for almost free. So kind of the next lesson for me, as I said, was that the time to recover is really no longer relevant as a concept. And then a lot of those architectural principles that we hold dear, like blue-green deployments, or having a failover version available, or having cold-started and kind of hot-started containers and things like that, they really become not that important anymore. And the big question then becomes, which other kind of development or design practices do we have that were influenced over the last 30 years that we're just using because our brains are hardwired to think about, well, what happens if this dies? And one of the kind of really interesting things that Lambda as a platform has forced us to do is actually, from the start, consider the fact that almost any part of this can die at any point, and that we just shouldn't care about it. Which then opens up some really, really interesting ideas around, well, where do you keep state? How do you ensure that the users are getting consistent information and things like that? So kind of it does solve a bunch of problems, but it opens up a completely different set of problems that's kind of really, really interesting. Kind of the third lesson is, again, this whole multi-versioning thing is absolutely amazing, especially because the cloud infrastructure is kind of magical. And a lot of the stuff that we are used to do, like I'm an automated testing geek, and I like to kind of automate testing on everything. But if you look at kind of the stuff around infrastructure testing, for example, what happens when your service disconnects from the database? Unless, I guess, you're NATO and you can launch a nuclear attack on a data center, that's impossible to simulate anymore. It's not something that I can cause. It doesn't depend on me. I can kind of try and prevent those things in the code, or I can kind of code around that. But with the whole idea of the infrastructure belonging to somebody else, then the big question is, well, how do you do development testing production? How do we upgrade things from one thing to another? And does the whole sequence of development testing production even make sense anymore? Or is that one of those constraints that we're working under? Because, hey, I can have 40 different versions now. I can progress that through a lot more kind of stages. So one of the kind of really interesting things about this, and I'll show you how Lambda's done it, I think the others are still catching up, so I don't think you can do something similar to Azure to this on Azure Functions, but if I do something like this, let's see, so to send a new version up, I can do, and I'll just say version dev, and then we can say release, and we will say version prod. So, so let me change the code. So if I say something like, hey there, so now this is going to kind of package up a new container version, going to send it up, and because I've used version dev, you'll see that the URL has kind of changed a bit. Come on. So the URL is now /dev, and we have numerical version 2. So I can set up all my data sources to call a numerical version 1 still, or call version 2. And if I kind of do this stuff now, it's gonna say, hey there, and I can now do npm run release, push up with the production version. That's gonna probably be version 3. I can then go and break the development version happily, and the production version is still going to be working, because they all have kind of a different version number. Kind of, I can set up a URL to be this or that. And the kind of the completely insane thing about this is that this is supported throughout the platform back to back. So if you have a service listening to queues, listening to emails, listening for file conversions, listening for anything else, you can say, well, you know, always call the prod version, or always call the dev version, or always call version Gojko, or always call version London. And kind of because this is so cheap, and not so cheap, it's the equivalent amount of cost, actually. What this allows us to do is, say, create a version of our system that only works for people in London and experiment there. And once we're happy with that, expand it to the rest of England. Or create a version just for people at this particular conference and go live very, very quickly because of the constraints that these people have. So it's kind of opening up the holy grail of agile development, where instead of dividing the solution to kind of release it, you slice the problem. You solve a smaller problem for a smaller group of people very quickly, and then kind of start expanding on that. And it creates kind of this whole idea that you can do small and valuable stuff very, very quickly. So since moving to this, we've been able to kind of slice our stories and releases much, much thinner than we were before, because the infrastructure is kind of built to provide that and built to support us in doing that. So, come on. So the kind of the next big lesson for me is that the true benefits of this thing actually come from embracing the platform, not just kind of using it as a service. Once we started moving from Heroku to Lambda, we were still under the mentality of, oh, you know, we're just going to use this as a cheap way to run web servers. Or we're just going to use this as a cheaper way to run queue processing, and everything else is going to be under our control. Kind of, we're going to keep usernames and passwords in a database. We're going to kind of authorize everything ourselves, because that's kind of, at the entry point of the server, I'm going to validate that this is a valid user, and then I'm going to kind of trust the requests coming out. And that just creates an unnecessary bottleneck. It creates kind of more services that need to be used, and different kind of routing and different constraints, where the lovely part about the whole kind of Lambda thing, and I think kind of if you're in the .NET space, Azure Functions are moving into that as well, is it just becomes a very, very easy thing to glue together the other services available on the platform. Kind of one thing that we've kind of started looking at is, and I think that's probably behind this kind of marketing stupid buzzword of serverless, is that the traditional roles of a server process are taken over by the platform, where one of the kind of key traditional roles of the server process is to be a gatekeeper, where you're sending a potentially risky request to a server. The server does input field validation, it does sanitization, it does authorization, it does authentication, and then after that you kind of trust that thing. But what that means is that basically you have to get somebody to talk to one server that then talks to other service, then talk to other service, just kind of blocks all these threads unnecessarily. Where what Amazon is kind of offering here is a distributed authentication service. So they have 5 or 6 ways of authenticating requests, but one of them is kind of Cognito, that allows you to create policies for browsers to talk to services like S3, queues, the database access directly. And the server process no longer needs to authorize that. They have distributed authentication working on the Amazon scale, which means that kind of this whole thing can get pushed out, and I no longer have to get a web browser to go to a server to wait until kind of some much more highly scalable service goes out. So, for example, for MindMap, one of the kind of heaviest processing things are file conversions. It takes a couple of seconds to produce a PDF. So what I can do is I can get a browser to send something to a server, then wait a few seconds until something else converts the PDF, then kind of send it back. Or I can kind of let people actually upload directly to S3, which is stupidly scalable. Then get a Lambda to kick off when a file was uploaded to S3, and kind of save it back to that same S3, and get the browser to talk to S3 and get the file back. I've just removed all the bottlenecks in my software and pushed it to Amazon scale. And I don't have to pay for most of that processing anyway, because I'm not waiting on anything, the browsers are waiting, which means that kind of the client is paying for CPU time effectively on his machine. So that opens up some really, really interesting possibilities on reducing the operational cost of the app, reducing the time it takes for something to run, because we can use these services that are built for ridiculous scale without even having to think about how do we kind of get 1 million people to upload files at the same time. Like, Amazon's dealt with that. The other thing that kind of the platform can take over, if you're not kind of too scared of that, is scaling. And in my previous life, I was a CTO of a startup. I worked as an architect for a gambling company. I've done lots of kind of things where I needed to be very, very smart and kind of decide, how do I ramp up, how do I ramp down, how do I manage operational costs for how many databases, how many servers, and things like that. And the more and more kind of we push the services into Lambda, we realize that if we design this thing properly, so it's not really the bottleneck, then we just don't care about the whole thing. Because deciding how many containers you run, or when they shut down, or what you need to do with those things, kind of works pretty well actually. Because I assume they had to do it for Amazon scale anyway, so kind of you just benefit from all those algorithms. And the third really interesting kind of traditional role of the servers that's actually causing a lot of change, it caused a lot of change in our software, is orchestration. The server process would normally do orchestration. You'd get one request and then it would say, oh, I need to send it here, I need to block on this queue, and after that I need to do this, after that I need to do that. And you can kind of still do that with a Lambda container, but at the same time, that means that kind of you're just paying for something that doesn't actually need to execute there. Because most of the, at least for what we were doing, most of the orchestration was done in a single process because we were scared to let the clients do orchestration. I authorize it in one place, and when I've authorized it in that place, I can orchestrate. Because we can now use distributed authentication, every single function gets, oh, I can call you, or he can call you, or only this group of services can call you, or this Lambda function has access to this and that. The whole problem with orchestration in one place goes away, and we can let the client code actually do orchestration. So we've pushed an insane amount of orchestration logic to the browser, where kind of it executes at horrible scale because, or at a massive scale because every single client that comes adds another processor to your application. And you no longer have to worry about any kind of capacity for orchestration there. But that's taken kind of a bit of a mental shift for us to realize we can do that and to start re-engineering the app. Amazon is also offering several workflow engines for kind of orchestrating this whole thing. So even if you decide to you need to do orchestration on the kind of platform side, it's not necessarily something that has to be done in a server process. It can be done through different workflow engines. And for me, that's one of the biggest kind of mental changes that we had to do to actually embrace the platform. So kind of the last big lesson for us migrating the whole thing was that serverless as a kind of buzzword and as a platform is often sold to people as stateless. You kind of just think about every request executing independently, you design your app like that, and it's all magical. Where the current implementation is actually not. The designing for stateless actually caused us to shoot ourselves in the foot a few times because the environment is not actually stateless. The environment spins up containers on demand and reuses containers as it wants to reuse containers. And there's pretty much no guarantee that two requests from the same user will hit the same container, even if they are kind of in sequence or parallel. There's no guarantee that they will hit different containers as well, which means that that's absolutely something you cannot influence. And for example, a couple of times we shot ourselves in the foot by caching stuff because we realized, we can cache a database connection. And then it realizes that the next request coming in, we're using a completely wrong database connection because it's cached. At the same time, there's lots of people complaining, especially kind of trying to use traditional SQL databases that cost a lot to contain in terms of connect to in terms of time. So, it costs a couple of seconds to connect to an Oracle instance. If for every single request you want to connect to an Oracle instance because you're treating it as stateless, you're just paying a stupid amount of money because you can kind of reuse some of the things, but don't reuse stuff that you shouldn't. And this kind of gets overly complicated with multi-versioning because the containers are tied to numerical versions and not tied to kind of environment labels. I've kind of deploying the previous thing. I've shown you that I now have development and production, but I also have version 2 and version 3. And there is actually just a quick way to reassign labels as well. So I can reassign production to version 4 now. And because containers are tied to numerical version, a couple of times what happened to us is we'd spin up a service to test it well. And we use the testing label, we tested everything we want, and then we reassign production to that numerical version. And it ends up we're just kind of reusing cached testing environments. And it's going to a testing database and things like that. So kind of Lambda deceivingly remembers. And you need to figure out that it's not remembering more than it should. And thinking about this as stateless is not really good, especially kind of, for me, stateless means that I can ignore the environment. I can pollute the temp file space. I can leave memory kind of taken. I can, just stop a request halfway through and, ignore what happens with the rest of it. But the current implementation actually is not doing that. One of the most surprising things for us was that Lambda, by default, if you're using Node.js, is configured to respond to a customer request as soon as you provide a response, but not actually kill the container until all the events from the event queue are emptied out. What that means in kind of plain English is if you connect to a third-party service and the HTTP request takes too long, and you decide, I'm just going to say this took too long, and tell my user, hey, it's kind of too long, timeout, but you don't actually kill the request going to the other service, that container is stuck. And the next request coming in is just going to be stuck. And this caused some weird timeout issues before we realized that. Now, of course, you can kind of reconfigure those things, but it's really not useful to think about this thing as stateless. It's much more useful to think about it as probably hundreds of containers running and kind of share nothing architecture where you do need to clean up after yourself. You do need to kind of think about that multiple requests might come into the same thing and you need to isolate them properly. And if you're using multi-versioning, the same container that was 2 seconds ago used for testing might now be your production. And that was kind of a massive kind of brain melt for us until we realized that we need to isolate these things properly. Now, of course, there's lots of support for doing that. Once a function is executed in Lambda through an event, you do get the context of is it production, is it testing, is it development, is it version 25 or 26? And kind of there are ways of then saying, well, I'm going to cache connections for my current label. So I'm not going to cache the database connection as a variable. I'll cache it in a hash map that says, I got called with production. Do I have a production connection? And things like that. But it's much more useful to think about this as designing for share nothing than designing for stateless. So kind of as a kind of finish to this, I think generally kind of the strengths of this whole new world that's emerging. And I think there's a ton of changes that are coming. In November, Amazon did this reInvent conference where they've kind of released a ton of new features and changed a bunch of things. So this is kind of changing all the time. But I think kind of one of the biggest strengths of this as a platform for developers is that time to deploy is minimal. Takes a couple of seconds to kind of upload the new version of the code there. And if you're using Node or Python, it takes less than a second to spin up a new container. Time to recover with something like that becomes irrelevant. And the really big question that kind of is, messing with my mind at the moment is which of the things I'm just used to do because, I've been taught to do it like that are because I'm protecting against long time to recover. And it's really kind of causing me to revisit lots of these kind of practices. The biggest advantage of Lambda as a platform for companies that are kind of operating software as a service is multi-versioning because it opens up brilliant possibilities of limiting, this version to 10 users, opening up this version to 100, running a version for London, running a version for UK, running 20 different versions, and kind of it just costs the same amount of money, which is brilliant. And I think a lot of kind of our current software practices are based around how much it costs to operate a version of software, which is no longer a constraint with this platform. For us, the whole platform forced us to kind of be much more strict about small and isolated code modules. Lambda is a event-driven processing thing, so you can make a Lambda get called on a HTTP request, a database trigger, a record being deleted, an email coming in, a message coming onto the queue, analytics record popping up, and a ton of other small things that kind of can cause stuff to do. And what's really forced us to do is break away this kind of mentality of building up large modules that need to be deployed together and doing these very small, single-purpose, single-usage modules that have their own containers. And one of the really interesting side effects of that is I've realized we are throwing away and rewriting software a lot more than updating it. We've rewritten the PDF exporter about 4 times so far. And because it's about 100 lines of code, when we need to introduce a new feature, we very rarely kind of go and update it. We kind of throw the whole thing away, keep the knowledge we did for writing the previous 100 lines, rewrite it from scratch using a new exporter or something like that. So it allows us to kind of, this whole legacy technical debt thing is no longer a problem. I can afford to throw away these small pieces of code all the time and rewrite them because the platform has forced me to create small independent pieces of code. And by the way, because multi-versioning is there, it doesn't matter. I can kind of rewrite this and still use the older version if this one is kind of borked. And it's 2 seconds to kind of rewire the code to use the old version. So the another really interesting strength of this as a platform is that you do get very, very fine-grained cost of operation metrics. There's kind of a synergy of the platform forcing people to do small isolated modules and having to kind of build this thing correctly, so you do get to kind of learn that, oh, you know, this particular function is costing us £500. Or this particular function is causing a 10-second delay in the process. And then you can do educated guesses around where to optimize, how to optimize, and what's really not worth even kind of touching at this point, which I think is absolutely amazing. And the last big benefit of this is kind of from a perspective of embracing the platform is you do get to use services that are built for massive, massive, massive scale. A week ago, we built a chat system for browsers that can potentially support millions of concurrent users in about 2 hours. Because we abuse the AWS IoT gateway that does WebSocket support. So I can do distributed auth, allow the browser to directly connect to their WebSockets that are built for stupid scale. I can have a Lambda function receiving those kind of messages, responding to it in an automated way if it needs to. And because we can use these things built kind of for massive scale, we've built something that, I don't know, 7 or 8 years ago, I worked with this gambling company. They were paying a third-party provider to push messages to browsers, something like, I don't know, 100,000 quid a month, where now you get that for free. And you get it so that it's, you know, probably built at better scale than what these guys were offering. And you get it with distributed authentication, logging, authorization, everything, and you can use it in about 2 hours if you can kind of wire these things together. So I think this is kind of just the beginning of this whole, you know, again, Gartner's estimate that it's going to be 75% platform spend in a couple of years, because we'll be using a lot more of these services. And if you are a service provider here, this is a brilliant opportunity to kind of, you know, plug a service and just offer it to other people like that so they can use it at massive, massive scale. Kind of in terms of the weaknesses, the biggest weakness for Lambda at the moment, I have most experience with that. I've kind of looked at the other platforms, but I can't really kind of talk about them, is you do not actually get any strong SLAs. The stuff works. We've never really had big problems with it. There was a day where it was working slightly slower over the last year. So for my performance needs, for my risk levels, that's okay. But there are no SLAs offered on this. So if you need to kind of support 99.9999999, it's probably not for you now. It doesn't mean that it's not going to be in 2 years, but at the moment, it's just not there. The other thing is the whole thing is built for throughput, not for latency. The latencies we're seeing are a couple of 100 milliseconds to kind of get the browser to execute something and kind of return it back, which is absolutely fine for most web applications. We've moved from dedicated VMs to Lambda, and we have really good monitoring on kind of end-user request timings. We've not really seen any big changes there. But high-frequency trading, anything that depends on kind of sub 10 millisecond latency or stuff like that, just kind of, this is not the platform for that yet. Technically, there's no reason for it not to be. It's just not there yet. I guess they need to improve capacity, performance, and things like that. The other thing is, there's similar to kind of no SLAs. There's kind of, they're not really offering any PCI compliance or anything like that. So kind of storing secure data, no. Storing any kind of data, generally no, because anything can die at any point. But storing and processing cards, storing and processing kind of sensitive data, probably not at this point. Amazon does offer a couple of other services. They have this thing called the key management service that's managed encryption with hardware and things like that, but that's not that cheap, and it's not that performant. So we've kind of farmed out our payments to PayPal and Stripe and things like that. So again, it's going this direction where you do get forced to use other services, all kind of platforms for that. The big problem, or not a big problem, but kind of, the inherent thing about the platform being something that controls the scaling and spinning up and scaling down is that there's no good way to keep an open connection from a server process to something else. We tried to build a Twitter bot, and Twitter doesn't have webhooks. The way you communicate to Twitter is you start up a process that connects to a kind of data feed, and they will pump stuff into your data feed. But you need to keep an open TCP connection. That's not really possible to do with Lambda, because Lambda is limited to 5 minutes total execution. AWS will kill it after 5 minutes and restart a new server. So yes, you could, do something where it kind of dies on its own after 4 minutes 59 and then starts up another process using async and then do this and do that. So theoretically it's possible to do that, but it's not really kind of the cleanest thing to do. And I think generally keeping open connections is not something that the platform is designed to do. So it's going to force kind of a redesign of that. Another weakness I think of this thing as a platform going into the future is it does actually, in order to get the financial benefits, in order to get architectural benefits, require a complete rethink on lots of the stuff we used to do. Like how do we do versioning? How do we do deployments? How do we do caching? How do we do authorization and things like that? You could literally take a kind of Express app or something like that as a web app, migrate it to Lambda. It will kind of work, but it's not going to give you any benefits of this stuff. So I think it's generally going forward, the whole kind of function as a service, serverless, the real benefits are breaking down the application into modules, not keeping these kind of monoliths running. And like with anything that's so dependent on lots of different moving parts, configuration does become quite a big challenge. And there's a couple of configuration tools and platforms. Amazon is slowly building up something they call Cloud Formation, which allows you to kind of configure the whole landscape, do transactional deployments and things like that. But it's still catching up, and I think the platform is moving a lot faster than the configuration tools. That's why a ton of other open source tools emerged in this space to allow people to configure deployments. The thing I showed you earlier was actually something that we open sourced as kind of and built as part of suffering through configuration challenges with MindMap. There's a couple of alternative platforms. The most popular one is called the Serverless framework. When we started MindMap, that was in kind of migrating MindMap, that was in February last year. I very quickly realized I'm too stupid to use the Serverless framework. Because it was overly complicated for what we needed. I think they've simplified it significantly since then. There's another thing called Apex. There's a couple of things kind of for most popular platforms. Amazon does their own thing called Chalice for Python. I think they've released support for .NET recently, so I don't know if there are any .NET deployment tools for that. But configuration really does become a challenge, and the first Lambda function we did just with kind of shell script deployments had 20 lines of code and had 140 lines of deployment scripts. At that point, kind of testing the code is irrelevant. You need to test the deployment scripts. And that's why we kind of ended up, again, I'm a testing geek, so I wanted to unit test my deployments, and that's why we built kind of a deployment tool that's kind of properly tested, so I can trust it. And kind of the opportunities, I think, that are coming out of this for people are kind of, first of all, this really is a next generation kind of a deployment architecture. And Simon Wardley had this post a couple of weeks ago where he said that if your organization has not done DevOps yet, just don't bother. Because kind of use serverless, and 99% of what DevOps is will be provided for you by the platform. So there's not much point kind of chasing up this, because in 5 years' time, it's going to be much cheaper anyway to pay Amazon to do everything for you. And you might as well just skip the whole generation of upgrades then, as kind of process architecture and everything like that. So the other big opportunity, I think, although kind of I see that as partially a weakness as well, where we need to rethink all these things, actually getting people to rethink the best practices is kind of not that bad, because we can figure out how to run faster. We can figure out what part of our code do we not need to maintain. We can figure out, are we kind of running with those shackles that are no longer applicable because we're still thinking about mean time to recovery and things like that. I've mentioned that they've released a way for people to actually sell their APIs through Amazon. And this kind of opens up some really interesting possibilities to change billing models, where at the moment, people are typically paying for using an application or some kind of a subscription, but with so low-level visibility and such kind of great opportunity for metrics in the whole thing, there's a possibility to actually bill people for individual functions if we're offering a service. So bill different people more for different types of usages, or kind of, and pretty much all this stuff comes more or less for free. What I hope we're going to see more, especially with kind of these estimates where, billions and trillions worth in platform services, is that there will be actually kind of marketplaces opening up for these services a lot more. So I think that's probably where, I don't know how much money Apple and Google are making on their app stores for mobile apps. I think we're going to start seeing API stores very soon, where you will be able to kind of develop an API, and it's going to be operated and run by the platform. They're going to provide billing, they're going to provide charging, and you get paid the money or some percentage of the money there. And of course, they'll take a cut, but then again, with the whole, I said we deleted 30% of our code, so I'm happy to give somebody 30% of the profit there just because they don't have to write it. It's kind of financially makes sense. So, and I think kind of the whole A/B testing that opens up for backend as well is amazing, where most people are just not doing that at the moment. A/B testing is something that's kind of typically reserved for front end, where now it becomes free. So kind of why not use that? And kind of to finish this thing off, I think kind of there are two important threats here that people need to worry about. The first thing is really kind of everybody's talking about vendor lock-in, and not vendor lock-in in terms of the code. There's relatively little code there that's not my business code. I develop a Lambda to say, hey, a request came in for file conversion. This is how I do file conversion. So, I can drop, hey, a request came in, and rewire it to another platform in 10 seconds. The big problem is the actual benefits out of using something like this come from embracing a platform. So if I've deployed on Amazon, I'm going to use S3, I'm going to use Dynamo, I'm going to use the IoT Gateway, I'm going to use a ton of other Amazon things just because that's how I get benefits from this platform. If I'm deploying on Azure, I'll probably use the Azure SQL service and their web services and their queues and their authentication. And I think that's kind of a massive, massive platform lock-in. So for me, I've been really happy running on Amazon, and I don't really care about being locked into Amazon. But if people are scared about vendor lock-in, this is going to be horrible. And I think the really kind of interesting risk here is that as we are pushed to use more and more of these platform services, the software will become a lot more reliant on third parties. Which means that the big risk in testing is not kind of your code being broken, it's somebody else somewhere else changing something without telling you, and then kind of start behaving differently. And that now kind of starts creating this whole problem of probably testing in production a lot more than testing before production, kind of having much better monitoring, much better kind of operational awareness. So those are kind of threats, I think. So there's two links for kind of more info here. If you want to look at that kind of tool I've shown you to deploy stuff, that's claudiajs.com. And I tend to blog about these things a lot because my mind's exploding at the moment with all the possibilities. So there's some more articles on my website. I think I slightly ran over time, so I'll probably kind of just go outside and answer any questions you might have, and we'll let the other people come in. Thank you very much for kind of spending this morning with me, and they've told me, please, please, please rate the session. I shall personally kill a kitten for anything that's not green, so thank you very much.